Welcome back. Let's talk about atomic mass and how we would calculate the atomic mass of an element. So even the largest atom has an extremely small mass. In the 1920s, we were able to determine the masses of the atoms using a mass spectrometer. You don't need to know any dates, but we found that a fluorine atom was 3.155 times 10 to the negative 23rd grams, and that's very, very small. So we had to use something that was a little bit more convenient, or numbers that were a little bit easier to deal with. So we decided to compare all elements to a reference isotope, and carbon-12 was the one we chose. And we defined then the atomic mass unit to be exactly 1/12 of the mass of a carbon-12 atom, which would be 1 proton or 1 neutron, would be 1/12, because carbon-12 has 6 protons and 6 neutrons. So since it has 6 of each, then they set the atomic mass unit for carbon as 12, and they measured in reference to that. Therefore, the mass of a single proton or a single neutron is 1/12 of 12 AMU, or 1 AMU. In nature, most elements occur as a mixture of 2 or more isotopes, and each isotope of an element has a fixed mass and a natural percent abundance. And that's what we need to know, is the mass of the isotope and the percent abundance. So here we have our masses for the first, like what, 2, 4, 5 elements here with their percent abundances, and then we have their average. And so we're going to do this calculation. You've done it already in class. We would change the percent into a decimal, multiply by mass, add the 3 up, and you get, or the 2 up, and you would get the average atomic mass. So chlorine has 2 natural isotopes, 35 and 37. If you were just to add the 2 masses together and divide by 2, you would get 35.986, which is not the right answer. So you cannot, I repeat, cannot add the masses together and divide by the number of isotopes. That will not get you the true value. So you need to do what's called a weighted average. You need to take the percent abundance, convert it to a decimal, multiply by the mass, and add them all together. So the atomic mass of an element is a weighted average mass of the atoms in the naturally occurring sample. And so the sample is the same throughout the world. The percent abundances do not change whether you're looking at something in England or Ireland or US or somewhere else. Now, maybe if you went to another planet or another star system, that may be different. I don't know. So we have two copper atoms here, copper 63 and 65. Since the average atomic mass for copper is 63.546, which one of the 2 isotopes is more abundant? Well, it would be more abundant to have the one that's closest to that average atomic mass, and 63 is closer than 65, so the most abundant of these 2 isotopes would be 63, copper 63. To calculate the mass of an element, you're going to multiply the mass by the isotope's natural abundance as a decimal, and then add those products together. Here in the book, they show you calculating out this number plus this calculation, and I prefer you do it all in one calculation, get right down to this number here, and then round according to significant figures. Why is the atomic mass of an element not a whole number? Well, that's because it is a weighted average, and so it is not just one isotope. Oh, we're to the key concepts, almost done. Elements are different because they contain different number of protons. Isotopes of an element have different numbers of neutrons, so they have different mass numbers, but they have the same number of protons. To calculate the atomic mass of an element, you multiply the mass of the isotope by its natural abundance expressed as a decimal, and then add them together. Number of neutrons is equal to mass number minus atomic number. So your vocab: atomic number, mass number, isotopes. Atomic mass unit, which is the mass of 1/12 of the carbon-12 atom. And atomic mass is the weighted average of the masses of the element's isotopes. Electrons in the structure of an atom. The atoms have the same element, have the same number of protons, which equals to the atomic number. Atoms have the same element have different numbers of neutrons. Atoms of the same element have different number of neutrons are called isotopes. And we made it to the end. Thanks for listening. I'll see you in class.